Good morning. Today we're going to be doing Algebra 2 Lesson 10.3 on exponential applications. And we started this as a live lesson, so many of you have started this with me. We actually got through the first problem in example 1, which was example 1a. So we are going to continue, though, by starting through at the beginning, but you can skip if you need to example 1b and work on that. Okay, so you're going to be able to solve exponential equations using the one-to-one property. So we're going to talk about what that is. And this video is going to support Delta Math Lesson 10.3 EXP 121. And please, again, gather all your notes, both the live lesson notes and the rest of the notes for this recorded video, and upload those to me and I'm going to extend it to Wednesday, April 14, so you have enough time to get through this. There's plenty of time to get us through the end of the semester, as I said, so no worries. All right. I wanted us to revisit again what we've been doing with exponents for years and years and years. So if we're multiplying two numbers where the base number, and the base is b here, are the same, then all you're doing is you're adding the exponents. So this becomes b to the m plus n, okay? And the next one, though, is this one's kind of critical for what we're doing today. So this is what we call a power to power, or power to a power problem. Power to a power problem. And what you're going to do is you're going to multiply the powers, okay? So multiply the powers. And so what happens is, multiplication over here of m times n. And so this is going to equal b to the mn. Okay. All right. Now, a good example of this, just a real simple one, is x to the third to the fifth power. And so you're again going to multiply that. So that's x to the 3 times 5. Now what you're multiplying again is the exponent. So you end up with x to the 15. We're going to be working this today in the problems that we do. Now you also will be seeing negative powers, so I want you to remember that what's really happening here is when you have a negative exponent, that's something you want to get rid of. So you can do that simply by inverting this. Treat this like it's a fraction. Which it is, it's always assumed that a whole number is a fraction, just divided by 1. And that's going to be flipped, and so you're going to end up with 1 over b to the positive m. Okay? Now, the other scenario is where you start with a fraction where the negative exponent is in the denominator. All right? And so, again, you just flip the fraction. You put the b to the m in the numerator, and b to the negative m becomes b to the positive m. And, of course, that just simplifies to b to the m. Okay? Pretty simple. All right. Let's move on. All right. So we did the first problem here, but we're going to go through it again. That is, if you did the live lesson with me. So let's just go through this and see what we come up with. All right, so you see the problem here, and again, we're using the one-to-one property. So what I want to point out here at the top is if you've got b to the u, and that equals b to the v, so there's the same base, and so then u equals v. U equals v. And of course, these are the exponents. So I'm going to show you up here. You've got to have, the bases must be the same. For this to work. Okay? And then you need to recognize that, of course, these are going to be exponential. Well, it'll be set up as an exponential equation. So let's just write it this way. So this is exponential, or the exponents, will be written as an equation. So here are the exponents up here. Again, we're focusing in on these. All right? All right? So those are the things that you want to key in on. So here's our first problem. And what I'm going to do is, well, when you look at this, I'm going to first see, do we have the same bases? Well, we don't. So we're going to have to change that. We're going to have to actually go down here and change this 32 and this 8 to something that has the same base, if we can do it. So let's see if we can. Well, I know that 8 and 32 are both even numbers, so I can divide them by 2. So let's just start with 8 because it's lower, and I'm going to get my calculator out here. Let's just see what times what equals 8. Well, we can do that in our head. 8 is 2 times 4, and 4 is 2 times 2. So that's 2 to the 3. So I'm going to write 2 to the 3 down here. All right? Now, 32, I know I can divide it by 2. So let's just see, let's go to turn this silly thing on. And we already know that 2 and then exponent 3, or 2 caret 3 is 8. Let's see what 2 caret 4 is. So 2 caret 4, or 2 to the 4th, is 16, not 32. Let's try one more time. I think that'll get us there. So 2 caret 5 is 32. So let me bring this up, and let me also turn my light on, and let's lighten this up a little bit. Whoops, I don't want to increase the size. I want to go down here. There, I think I can see things a little bit better. All right, so maybe I don't need the light on. 2 to the 5 is 32. Okay, so this is 2 to the 5 then. 32 is 2 to the 5th. All right, so we're going to do what we had set up before. We're going to we're going to go ahead and set this up as a power to a power thing, because I've got 2 to the 5. I'm going to now put my exponent, which is the n in the first one, on the outside. So 2 to the 5th, and then I'm going to do parentheses. And now I'm going to put this exponent over here. So I have 3x minus 3. Okay. And I'm going to put that in parentheses as well. And then 2 to the 3rd, put that in parentheses. And then to the x minus 1. And I'll put that in parentheses as well. So now it looks like the power to power situation that we've got right here. Okay. So now that we've done that, what we want to do is we want to distribute. We're going to go backwards. We're going to actually deliberately go from here to this situation here. So I'm going to distribute the 5 to the 3x minus 3 and the 3 to the x minus 1. So 5 to the 3x, and so that's going to be, well, let's just do this. Let's get the arrows in here. And I'm going to distribute this here, 3 to the x and the 3 to the negative 1. Okay, so this on the left, 2 to the 5th times, 5 times 3x is 15x. And 5 times negative 3 is negative 15. Okay, and put an equal sign in between these. And then I have over here on the other side of the equal sign on the right, 2 to the 3 times x and 3 times negative 1, which is negative 3. Okay, so I've set up a new equation, and again, we're going to cue in on the 15x minus 15. Now here's where it gets kind of wonky. So let me grab a sheet of paper here. I did this demonstration at least at one of my classes. So my base is 2. That's my base, 2. I'm going to take that 2 and I'm going to toss it. And instead, I'm going to just deal with the exponents. Let me adjust the focus here. It looks like it's a little bit off. Let's see, is that the focus here? Okay. So, we want to go ahead and get rid of the common base. So that's what we just did. So we got rid of the common base. And we're going to leave ourselves with 15x minus 15 equals 3x minus 3. Okay. So we got rid of and I got to scrunch a little bit more because I have this second problem. And so now the next thing I want to do is solve the equation. Now if you look at the equation, it's just a linear equation now. There's no exponents in it, so it's going to be real simple. Solve the equation. And of course, this is created by the exponents. So the first thing I want to do is simplify and undo. And so I'm going to subtract, let's see, I want to get the x's together. So I'm going to subtract 3x. So subtract 3x here, and I'm going to subtract the 3x over here. And when I do that, I'm going to get 12x minus 15 equals, this goes away, it's eliminated, 3x and the negative 3x, and I'm left with negative 3. All right, and then the next thing I want to do is I want to add 15 to both sides because I want to get the 12x by itself. And the opposite of subtract is to add, so that it eliminates the 15 on the left side and brings it over to the right side. That's all part of undoing. So I'm left with 12x. Let's move this up. 12x, and then this is eliminated, the 15 and negative 15. 12x equals, and negative 3 and 15 is 12. And then the last thing I want to do is get the 12 by itself. I'm sorry, not the 12 by itself, the x by itself. I want to, again, I'm solving the equation, simplifying and undoing. So what I want to do is isolate x, meaning get it by itself. By itself. And that's the process that I've been doing here. So divide by 12, because this is multiplication between the 12 and the x. And I'm going to divide the 12 on the other side by 12. And 12 divided by 12 is 1. That leaves me with 1x. And 12 divided by 12 over on the right is also 1. So x equals 1. Now we want to check this on a graphing calculator. I want to make sure it's right. So I'm going to take my graphing calculator over here, and I'm going to go, maybe this time I'm going to turn the light on. I'm going to go back to my original equation up here, and I'm going to put the left-hand part of the equation into my y equals, and in this case my y1. So let me turn this on. Let's clear, and let's go up to y equals, and in y1 I'm going to type in 32 to the 3x minus 3. So that you do this by typing 32, and then your caret, and then in parentheses I'm going to put 3x minus 3, and close the parentheses. Okay? And now I'm going to toggle down to y2, and I'm going to put 8 to the x minus 1. So I'm going to type in 8, and then the caret, and then parentheses x minus 1, close the parentheses. All right, so I should be able to graph this. So I'm going to click the graph button, and it's slowly resolving. There's the first side. Hopefully the second one's going to show up. Yep, okay. So you see the two functions, and they appear to be crossing over here. Now it's hard to see, but the way the standard scale is here, these are 10 units to on the x-axis on the right side, and 10 units on the left side, and the y, it's the same thing, 10 units and 10 units. I'd like to enlarge this so I can see it better. And so what I'm going to do is I'm going to go over here to this window, and I'm going to change the settings for the x and the y. I'm going to change this from 10 to I think 2 units is going to be enough from the looks of this, because this looks to be about x is 2 here and y is 2 up here. Okay. So we go to the window, and we're going to change the x min to 0 right on the x-axis. And I'm going to toggle down and go, and the x max I want 2. And then I'm going to toggle down to the y minimum, and I'm going to make that also 0. And then I'm going to toggle down to the y max, and I'm going to make that 2. And then I'm going to go back to graph. And so you can see here that I have, here it is, where it crosses, and it may be hard to see the little tick mark here, but this is x is 1. And down here, this is x is 1. So it looks like it's correct, but just to be absolutely certain, what I'm going to do is I'm going to go to calc, which is this blue entry that's above the trace button. So we'll click second to get the calc and press trace. And then I'm going to go down to number 5 where it says intersect, because I want to find out what the spot there that's at the intersection, what that's worth. So it says first curve. So what I do is I go over here to this button, and I'm going to scroll to the left, and let me up the zoom a little bit here so you can see this a little bit better. So I'm gonna push the left side of this button here, and what it's going to do is move the cursor down the graph that's steeper. And since I've got it to move down once, that's all I need. So I'm going to hit enter, and it's going to say second curve. Now what it's going to do, I'm going to push the right button, and it's going to bring it over onto the other. You can see it's now gone over to the other function, and so they crossed both of them. And so now I can hit enter again, and it says yes, yes. And so x equals 1. That's what we need to know. And coincidentally, y equals 1. We've just proven that this checks. We know that we've got a correct answer here. All right, so this is correct. All right, so now we're going to go over to a more difficult problem. Let me reduce the zoom on this. Let's see here. Okay, so we want to do this. Now this is another equation, and but we're going to do it the exact same way. Okay, so let me just get my notes out here. Okay, so we're going to go ahead and do exactly what we did before. So I'm going to take the 216 and I want to figure out what 216 is. What is it to the power of? Okay. So looking at 216, I've got to figure out what its base is going to be, because wow, this one's more challenging. Look at this. Here's 216. Here's 1 over 279,936. Good Lordy, what's the base here? Well, if you look at both of these numbers, both of them look like they are possibly divisible by 6. So let's clear this graph, and let's clear over here the y equals. Let me clear all those things and go back here to 216. So let's see. We know 6 to 1 is 6. 6 to the 2 is 36. Let's see what 6 to the 3 is. So 6 caret 3. Oh, geez, it's 216. Okay. So this is 6 to the 3. Now this, well, right now, let's not worry about the fact that it's in the denominator. If that's the case, then my exponent is just going to be negative. But let's try 6 to the 4th. So 6 caret 4, 1296. Or at least we're getting up there a little more. Let's do 6 to the 5th. So 6 caret 5. And 7796. Okay. 6 caret 6, 46,000. Where it's not quite there yet. Let's try 6 to the 7. 6 caret 7. Oh, okay, 279,936. So we know then that this is 6 to the negative 7. Because again, we're in the denominator. Okay, so 6 to the 7 here, but 6 to the negative 7. I don't know if I could do it that way, but we could try. Well, let's not worry about that at this point. We know the principle. We looked at the original problem where when we were dealing with b to the negative m, we just moved it into the denominator, and then if it started out 1 over b to the negative number, then this is going to be negative. Okay. All right. So 6 to the negative 7. Now let's put our exponent in. So this is 6 to the 3. Remember, on the left, and then it's to the negative 5x plus 10. Okay. And 6 to the negative 7 over here, it's going to be to the power of negative x minus 2. All right? Let's put parentheses around each of these exponents. Now, here's the thing. These are still not, technically speaking, the same bases until we do the distribution. So let's go ahead and distribute. So we're going to multiply both of the terms on the left by the exponent of 3, and then we're going to take the negative 7 and we're going to multiply it to the 1x and to the negative 2. All right? So let's do that. So it's 6 times 3 to the negative 5x is 6 to the negative 15x. And 3 times 10 is 30. Okay, and then over here it's going to be 6 to the, let's put the equal sign in the middle. It's going to be 6 to the negative 7 times negative x is positive 7x, right? And negative 7 times negative 2 is positive 14. All right. So now we have the exponents that we want. And so we're going to do what we did before. We're basically going to throw away the bases. And we're going to go ahead and take the exponents and make them our equation. So I've got negative 15x plus 30 equals 7x plus 14. So now this is no longer that difficult. We're back to a linear equation. So let's solve the equation by simplifying and undoing. So I want to get the 7x and the negative 15x together. So this time I'm going to add the 15x because I want to get positive x's. It's just easier that way. And so the 15x and the negative 15x are eliminated, and I have 30 equals, and this is 7 and 15, that's 22 x's. Plus 14. All right, now I want to get the 14, get rid of it, because I want to get the x by itself, so I subtract 14 from both sides. And so 30 minus 14, let's see. Well, let's see, what is that, 16? 16 equals 22x. And the 14 and negative 14 disappear. They're eliminated. So 16 equals 22x, and now I want to get the x by itself, so I'm going to divide both sides by 22. So I get a fraction, 16 divided by 22. Now 16 divided by 22 equals x. Now we can simplify this. Looks like we can divide both of these, the numerator and the denominator, by 2, and so that leaves us with 8 over 11. So this should be our answer here, 8 over 11. Okay? And we could go back through and do the same checking before like we did with the calculator to figure out that. I'm not going to go, for the sake of time, I'm not going to go through that on this one. All right. So now we have another ugly looking problem, but remember these are going to be negative exponents, and we just have to figure out what the bases are. And so both of these are even numbers, so they've got to be to the power of 2. Wow. 4096.
Hey Jackson, come on out.
So well, let's just 4096. Let's see if we can divide that by 4. Let's take 4096, start with a smaller number. So 4096, and let's clear this. 4096, let's see if we can divide that by 4. Okay, that gives us 1024. Okay. So we want 4096. 1024, we could divide that by 4. 10024 divided by 4. That brings us to 256. 256 divided by 4 is, oops, that's wrong. 256 divided by 4 is 64, and so I'm just, we're up, what, 4, 5, 6 times. Let's try 4 to the 6 and see if that takes us. Let's go backwards now. 4 caret 6. Let's see if that is 4096. Yeah, 4096. So we know that that's going to be, the equation here is going to be 1 over 4096. So it would be 1 over 4 to the negative 6. But it looks like we could do this by 2's. So let's see if we can get it down lower. If we've got 4 to the negative 6, then it's got to be 2 to the negative 12. So let's try that. We're going to change this. We aren't going to look at it as a fraction, so we're going to do 2 to the 12. So 2 caret 12. We're just doubling, or going to a half of 4 and then doubling the exponent. 2 caret 12, 4096. So this is 2 to the negative 12. Okay? That's what that's going to be. And then let's see if we can divide 32,768. What would that be? Well, we're at 2 to the negative 12, and it's 4096. So let's see if we can get up to this. So 2 caret 13 is 8,192. 2 caret 14, 16,384. We aren't there yet. 2 caret 15 is 32,768. So 2 to the 15th is 32,768, which is what this is over here. So we're going to make it a negative exponent because remember we have a fraction. So we're going to change this one to 2 to the negative, what did we say? 2 to the negative 15. All right? All right, so now we know what the bases are. We got the bases the same. And so we're going to put parentheses around them, and then we're going to put the exponent up here with each of them. So negative 5x plus 10, bring down on the left, and that's going to equal, and then we're going to put parentheses around to the negative 12, and that's going to be to the negative 2x plus 14. And let's put a parentheses around each of these exponents. Okay, so now we're going to throw out the base. We're going to throw out the base and we're going to take the exponent. So this is what we want. We want to take this and this, and we're going to get rid of the base. Okay. So we'll rewrite this as, well, oh, we almost forgot. We have to first, before we do that, we have to distribute. So let's distribute. So we have to distribute the negative 15 to the negative 5x, and we have to distribute it to the 10. We have to distribute the negative 12 to the negative 2x, and the negative 12 to the 14. All right, so let's do that. And we'll write it down here. So negative 15 times negative 5, that's positive. Now let's find out. Negative 15 times, we'll put this, well, let's see if we can do it this way. Negative 5, enter, we get 75. Okay, and that looks right. So 75 x's. So I'm going to write 75x, and then negative 15 times 10, that's going to be negative 115. You know that because just add a 0, you know, to the negative 15. So that's 75x minus 150, and that's going to equal, and then this over here is going to be negative 12 times 2. Well, 2 times 12 is 24, and these are both negative, so positive 24x. 24x, and then negative 12 times 14. Let's do that in a calculator. So negative 12 times 14, and looks like I get negative 168. So I'm going to put down negative 168. Okay. All right, so we're back again to a simple linear equation. We want to simplify. We want to get x by itself, so we have to go ahead and let's get rid of, we got 75 and 24. Let's subtract the 24x. Subtract 24x on both sides. And that's going to give us, let's just do 75 minus 24. So that's going to give us 51 x's. 150, and that equals, let's see, this 24 and negative 24x are eliminated, equals negative 168. So now we're going to, we want to get the x by itself, so we're going to add, let's use, add 150 to both sides. And so we eliminate the negative 150 and the positive 150, and we get 51x equals, and negative 168 and 150, I think that's negative 18. Okay. So we're going to go ahead and divide by 51 on both sides to get the x by itself. And we're left with 1x on the left, so that's isolated, and negative 18 over 51, I wonder if we can divide 1 and 6. Maybe we can divide, let's see if we can divide by 2. 51 divided by 2, it doesn't look right. Did I do this right? 75 minus 24 is 51. So we would be leaving this then as negative 18 over 51. Because I can't divide by, what can I divide? Can I divide 51 by 3? Let's just see. I think it's a prime number. Oh, you can divide by 3. Okay. So if I can divide 51 by 3, let's see if I can divide, well, 6 times 3 is 18, so I can do that. So this would be negative 6 over 18. Oh, no, negative 6 over 18, negative 6 over 17. Okay. So that's going to be your answer. Again, you can check it the way we said before with a calculator. All right? And you'll want to do math frac for something like that. So let's do the last problem, and we can go ahead and finish off, and then maybe if we have time here, I'm going to do I'll try the math frac just to see if we can easily do that. All right. So again, we've got a fraction here. This is 7. Well, hopefully we can divide 343 by 7. And I think we can. So let's try. So this is 7 to the 1. 7 times 7 is 49. That's 7 to the 2. Let's try 7 to the 3. So it's clear. And 7 caret 3 is indeed 343. So this will be 7 to the negative 3. Right? So we'll bring this down, and we have, because it's a fraction, this is going to be 7 to the negative 3. Right? And over here, this is going to be just the 7. Right? 7 to the 1. And then we're going to, on the left, we're going to multiply the exponent times the power. And so the power is negative 2x minus 4. And then over here we have, in the exponent, 2x squared plus 4x. Now in this particular case, we're just going to leave this exponent the way it is because this is already 7. There's no distribution. The power is 7, 7 to the 1. 1 times 2x squared plus 4x is 2x squared plus 4x. But I do have to distribute the negative 3 over here to the negative 2x and to the 4. All right? So negative 3 to the negative 2x, so this is going to be 7 to the 2 times negative 2 times negative 3 is positive 6 x's, and negative 3 times negative 4 is positive 12. And then this is 7 to the 2x squared plus 4x. All right. Throw away the bases. So we want to get rid of those. And we're going to use the exponents. So I'm going to rewrite this as 6x plus 12 equals 2x squared plus 4x. Now, this is obviously quadratic. Okay? So what we're going to have to do is set this all to 0 to find x. So set y to equal 0. So that means I got to get all this stuff on the left side over to the right-hand side so that I got a 0 over here. So I'm going to subtract the 6x and then I'm going to add the 12. Well, let's just do it this way. Subtract 6x. So I get 12 equals 2x squared, and negative 6x, and 4x is negative 2x. Okay. Now I'm going to add the 12. Oh, I'm sorry, subtract the 12 to get rid of it. And obviously that's not a like, so I'm just going to tack it on to the other side. 12 and the negative 12 go away, and I'm left with 0 now, which is what I want, equals 2x squared minus 2x minus 12. So I've got a factor. But first, notice I've got 2's here in each of these terms, so I can, let's divide those out. So I'm going to divide out 2 from both sides. Now obviously 0 divided by 2 is 0. And I'm left with 0 equals x squared minus x minus 6. So I just factor. So I'm going to double bubble it. 0 equals, and then x squared is x times x. And then what times what equals negative 6. That when added together equals negative 1. Negative 2, no, negative 3 and positive 2. So let's put in negative 3, positive 2. And you can just, double check here. Negative 3x and positive 2x is negative 1x. Okay, so that looks good. So now I'm going to go ahead and make x minus 3 equals 0 and x plus 2 equals 0. And then if you remember, you just simply move over the negative 3 and the 2. And so you end up with x equals positive 3 and x equals negative 2. Okay, so you now have 2 answers that you're going to put into here. Okay? All right, so we are out of time. I did the calculations to check before. You can do that with all these. Just remember with fractions, sometimes you may need to convert them to decimals and then go back to mathfrak to do that. Over here you've got 2 problems. You want to make sure that you don't have one that's false. Double check both of these. Again, put the values in the calculator and you can do that. Okay? So if I take the 3 and I go back up here and I make this my y1, 2 times 3 minus 4 would be your exponent. Anyway, you would figure that out and see if it equals this side here. Okay, and you can also check it by putting 1 in y1 and 1 y2, looking at the graph, see the intersection, and find out if x is 3, and then put in negative 2 again into all of this, and then put the left side with the negative 2 as your x into y1, and the right side into y2 with, again, the negative 2 as your x. Check the graphs, see the intersection, and if it's negative 2, then you're good. Okay? And if you don't see it, if it isn't right, then one of these is false, and you can just determine which one it is. Okay. That's it. We're done, ladies and gentlemen. So I will let you go for today. Take care. Bye-bye now.